Hello and welcome back. We're coming to you from the studio in the downtown. As you can see, we have a large audience, and the topic today is methods of sampling. So let's begin. Presentation 1.3, methods of sampling. We want to acknowledge the development team, as you can see on the screen here. We want to look at very briefly what we looked over in presentation 1.2. We have the idea of a population being a set of all data items under discussion. And we take a random sample here, that's the red lines, and they're supposed to be truly random, that's why we've depicted them in this way. This becomes our sample, and we have associated with the population a characteristic called the parameter, which might be the mean, standard deviation, or a proportion. On the other hand, with the sample, we have a statistic which has these following symbols. Now you should take note of these symbols because we'll be using them throughout the course. The idea here is that we use these sample statistics to infer characteristics of the population in the sense you see on the screen here. Now, random sampling is a scheme whereby each and every item of the population has the same chance of being selected, and the best way to do this is using some sort of computer technique where we assign to each item of the population a number, and we use a computer software package to generate a random sample of n numbers, and we find out who in the population is associated with these numbers, and they become the items of our sample. We see here that this item, and we take a measurement. The data point is x1, it's our sample, and x2, x3, x4, and up to x of n. N would be the sample size. We want to suggest to you that the mechanism for generating these numbers should be such that no human intervention is involved. That the human is divorced from it. The computer actually generates the numbers. And this helps to eliminate bias. Now, simple random sampling is the method whereby each and every sample of size n has the same chance of being selected. And we're suggesting that this may involve a scoop, or if we have a large jar of pills, we have a scoop containing 100 dimples in it if you wish, and we just scoop out 100 pills. The provision here is that the batch is thoroughly mixed. Here's the example here. Put in a scoop and take our sample, and this is given to the patient, of course. Grain from a large bin. During a deck card game, a deck of cards, 5 card set, equally like was in the other 5 card set. Systematic sampling, on the other hand, is a method such that the items are laid out in space-time, and you take every 10th or 12th item and you randomize the starting point. So as you can see on the screen here, we have typically perhaps a production process. These are items coming off the assembly line. We randomize the starting point, usually with a die or whatever, starting at 5, and we go every 12th item, and we do this n times to constitute our sample size n. And we're saying that the problem here is that if there's certain wheels involved here, if there's a defect on one of these wheels, there will be systematically an error turn out in a periodic fashion. Stratified sampling, on the other hand, where the population is divided into mutually exclusive subgroups, or strata, or layers, and we take samples from each of these layers or strata, and typically we have strata might be gender, such as male, female. His attitudes may differ from male to female. Age groupings, under 25, 25, 50, over 50. The attitudes may differ here, especially if it involves same-sex marriage or attitude towards drugs or whatever. Geographical regions, across cities or municipalities, attitude or opinion might change. Education levels, high school, college, university, attitudes might differ according to these different strata. And geographical or proportional sampling is such that if we have several cities, we have the populations involved, we want a sample of something like 500, we take the ratio of 500 or 550 to 110,000. So that ratio is 0.5%, and so our sample size in each case is 0.5% of the population size. It's called proportional sampling, and we use this to account for the fact that each item has to have the same chance of being selected as any other, and this becomes our sample size across the various regions. Cluster sampling is involved where the population is divided into non-overlapping clusters, and we take a sample of these clusters and examine every item in each of these clusters. Note all items, that's the key word there. In a large city, we have city blocks, which might be clusters. We take a random sample of city blocks and examine every person within that block. Here's a case that's quite relevant. This region is a forested region, southwest Alberta, and the Forestry Service may have divided this into these tiny grids using GPS technology. Each grid may have a number, and we randomly select 15 numbers, and we find the point on the grid associated with those numbers. We go into each of these clusters and count the number of trees that are infected in each of these. Count the number of trees in each cluster, and this gives rise to the percentage or number infected. Finally, we get to convenience or volunteer sampling. This is the one where the individuals involved respond in as volunteers or in a convenience fashion. Typically, in an aircraft, after an aircraft flight, a feedback form is on the seat. Typically, individuals will respond to the questionnaire if they've had a bad flight, and that's why such sampling is generally considered not valid. You go to a bar and ask the 18 patrons at the bar about some drinking and driving process or legislation, and of course there's a bias in volunteer. And testing your understanding. We'll go through these. You can read them yourself. This would be called systematic sampling. I'll notice this would be cluster sampling. This would be simple random sample. And this would be stratified sampling. And this would be convenience sampling, and of course wouldn't be valid unless you're looking at patrons at a bar as your population. Finally, we have this final example here. This would be stratified sampling with random sampling involved in each of the strata. Well, that's the end of presentation 1.3. We ask you to review it once again, take notes as required, and go to presentation 1.4.